Hi, I'm Nic Raboy, and in this tutorial, we're going to see how to build a web API, so in particular, a REST API, using .NET Core and MongoDB. So if you recall, recently I recorded a video tutorial around building a console-based application using .NET Core and MongoDB. This is more or less a part 2 of that tutorial. So instead of building a console application, we're going to be building a web application, but it's going to take a lot of the concepts that we learned in that previous tutorial and apply them towards building API endpoints. Now, what you will need prior to starting this tutorial is you will need .NET Core 6.0 or higher. You'll also need to already have MongoDB Atlas deployed and configured. And what I mean by that is I mean a cluster deployed and configured. So that means having your users created, having your network access rules created, etc. If you need help doing any of that, there are previous tutorials that have been released on the Developer Hub from MongoDB, as well as the MongoDB YouTube channel. But if you're good with that kind of stuff, then we can jump right into the tutorial. So up on my screen, you'll notice that I do have my terminal open. What we're going to do is we're going to create a new web API using the .NET CLI. So what we can do is we can say .NET new web API, and we can say output, and I'm going to call it Mongo example. And I'm going to output this directly to my desktop. All right, let's go ahead and navigate into that project directory. And let's install the MongoDB driver for .NET Core. And to do that, since we're going to be using the CLI and Visual Studio Code rather than using Visual Studio and NuGet, what we can do is we can say .NET add package, and we can say MongoDB.driver. And what that's going to do is that's going to add the latest version of the MongoDB driver for .NET Core. So let's go ahead and open up this project in Visual Studio Code, or whatever editor you feel the most comfortable with. So within my Visual Studio Code, you'll notice that we have a variety of files. So for example, we have a weather forecast CS file, program, and a Mongo example.cs project file along with some settings files. What we're going to do is we're going to remove anything related to weather forecast, or if you really wanted to, you can just ignore it. We're not going to be adding to those files. Instead, we're going to be creating some new files for this particular project. Now, the way that this project is going to be structured is we are going to be having a MongoDB service, which is going to be responsible for actually connecting to MongoDB as well as interacting with MongoDB. We're going to have a controller for each of our endpoints. So our endpoint functions in that controller are going to communicate to our MongoDB service. And then we're going to have various configuration files and classes to represent our models for working with our data. So to start things off, let's go ahead and start by creating a single model. And this is going to represent our settings for MongoDB. So this isn't going to be related to our data, but this is going to be strictly related to our settings for connecting to MongoDB. So let's go ahead and create a new directory. I'm going to say new folder, and I'm going to call this one models. And within the models directory, I'm going to create a new file. And this new file is going to be called MongoDB settings.cs. Now, if I open up this file, what I want to do is I want to give it a namespace. So that way we can be consistent across our entire project. So we can say namespace. I'm going to call Mongo example.models. I'm going to provide it a class. So I'm going to say public class MongoDB settings. And within this class, I'm going to define the variables for holding our MongoDB connection information. So I'm going to say public string connection URI. What you call these isn't particularly important as long as we're consistent throughout the steps. We're going to give it a getter and setter method. And we're going to say that it can be null. And we're going to do that same thing for a few more variables. So we're going to have a database name, and we're going to have a collection name. The next thing that we can do is we can go into our app settings.json file for our project, and we can actually define the connection URI, the database name, and the collection name. So let's go ahead and add a new JSON object. So let's go ahead and call it MongoDB. This is going to be an object. And this object is going to have 3 fields. And as you probably guessed, those 3 fields are going to be related to the MongoDB settings.cs file. So I'm going to have a connection URI. I'm going to have a database name. And finally, I'm going to have a collection name. Just remember to be consistent in your naming convention so that way you don't run into any kind of errors. Now for this project, what I'm going to be doing is I'm going to be using a sample database, just like what we saw in a previous tutorial. If you need help loading sample databases, you can go to your MongoDB Atlas dashboard. You can click on the ellipsis menu next to your cluster, and you can say load sample dataset. So if I go into browse collections, and then I click on sample mflix, we're going to be using the sample mflix database, but we're going to be using our own custom collection. So we're in reality not going to be using any of the collections and data that's already provided to us for this particular sample data set, but our actual example is going to be inspired from this data set. So we're going to have a playlist collection that we're going to create. It's going to have data relative to, say, for example, a playlist of movies that a user wants to watch. And that's going to be the basis of our example. So we're going to be using the sample mflix database and the playlist collection. So if we went back into our editor, we can say sample mflix as our database, and our collection name is going to be playlist. Now in terms of the connection URI, let's go back into the MongoDB Atlas dashboard. Let's go ahead and click on the parent Atlas tab. For examples, let's go ahead and say connect, and say connect your application. Go ahead and pick the driver that we're using. So we're using C#.NET. Go ahead and choose the version that you want to use, and go ahead and copy the URI string that it provides. Let's go back into our editor, and we're going to paste it in. Now I already created a username and password, so I'm going to enter it in. Now I am exposing my username and password, but by the time this video airs, this username and password will have already expired and you won't be able to access my cluster, database, or collections. So let's go ahead and save what we have so far. Now what we can do is we can move on towards actually creating our MongoDB service. And like I said, this service is going to be responsible for actually connecting to MongoDB and allowing us to interact with each of our collections, documents, etc. So let's go ahead and create a new folder. I'm going to call this folder services. Inside of this services folder, I'm going to create a new file, and I'm going to call it MongoDB Service. .cs. Now, if I open up this MongoDB service.cs file, I can start adding some code. The first thing that I want to do is I want to import a few dependencies that we'll be using throughout this particular class. I'm going to say using mongoexample.models because we will be using that MongoDB settings.cs file over that class. We're also going to be adding a few more dependencies. So these dependencies will allow us to interact with our database as well as interact with the BSON data type. Let's go ahead and say namespace, and we're going to say mongoexample.services. Now we can define our class. So I'm going to say public class MongoDB service, and I'm going to define a few things. So for example, the first thing that I'm going to do is I'm going to create a read-only private variable that's going to represent our playlist collection. And that playlist collection is going to be accessible throughout this particular class. But of course, because it is private, it will not be accessible outside of this class because everything that we want to do is going to be powered through this particular service. I'm going to say private read only. I'm going to say iMongo collection. It's going to be of type playlist, which we haven't actually created yet. So I'll leave it blank, and we're going to call it playlist collection. Now, before we progress, it might be a good starting point to actually create that playlist collection or that playlist data type that I had just mentioned. So we're going to leave this error alone for now, and we're going to proceed to creating a new class. So within our models directory, let's go ahead and create a new file. So this new file, what we're going to say is we're going to call it playlist.cs. And it's going to behave similarly what we saw for the particular MongoDB settings.cs file, but with a few exceptions that it will be adding particular value around MongoDB. Let's go ahead and add a few imports. All right, with those imports out of the way, let's go ahead and say namespace. We're going to say mongoexample.models. And let's go ahead and create that class. And I'm going to explain what each of those imports is going to do for our particular class use case. So we have our playlist class. Let's go ahead and create our variables to be used, so our fields. Let's go ahead and say public string. This is going to be an optional string, so this is going to be ID. We're going to have a get and a set, and we're going to leave it as is. So when working with MongoDB, our documents will have an ID. So within MongoDB itself, that ID will be _ID. It is unique. It's something that you have to have as far as your documents go. We're going to call it ID locally within our C# or our .NET Core application. And we're going to modify it slightly in just a moment, but let's go ahead and get our other fields in there, and then we're going to see how it maps to MongoDB. So next up, we have a username. So this user maybe describes what our playlist belongs to. So we're going to say public string username. Going to have a get and a set. And this one, we're going to say that it can be equal to null. We're going to have a public list string, so a list of strings, so an array within our MongoDB documents. We're going to say movie IDs. Of course, it's going to have a get and a set. And we're going to say that it can be equal to null as well. Now, if you caught that other tutorial that I did when it comes to the .NET Core console application, a lot of this may look familiar to you. But we're going to do a few modifications to make it more friendly for a REST API or a web API. So starting with the ID. So we're using ID, capital I and then D, within our local .NET Core application, but it needs to be _ID when it comes to MongoDB. It also might be in our best interest to make it an object ID rather than a string, even though that our MongoDB document IDs can be strings if we really wanted them to. So let's go ahead and say bson ID. So this is going to be a bson ID. And what we're going to say is we're going to say bson representation, and this representation is going to be a bson type dot object ID. And what this is going to allow us to do is it's going to allow us to work with our data as a string within our .NET Core application. It'll be saved as an object ID within MongoDB. And if it doesn't exist, it will go ahead and create one for us. So that way we don't have to worry about creating string-based IDs. It'll just create a new object ID for us. So we have our username. We're going to leave that as is. So it's going to map directly as username within MongoDB for each of our documents. But then for movie IDs, let's say that we don't want the movie IDs to show up within our documents as movie IDs, but maybe we want them to show up as other types of fields. This is completely optional, but I'm showing this because it may be something that you do in your own application. Maybe you already have a pre-existing data set within MongoDB, and you need your .NET Core application to accommodate. So let's go ahead and do the following. We're going to say bson element. And our bson elements, our bson field, might be called items. So within our database, within our collection, our document might have a field called items rather than movie IDs. So that's how we're going to map the two. Also, because this is a web API, we're going to be returning data to our client as JSON. Now, if we did nothing else, our bson would be items, our local field would be movie IDs, but our JSON would also be movie IDs. So let's say that maybe we want to work with our data in JSON terms also as items. So what we can do is we can say JSON property name, and we can call it items as well. And we're going to save it. So we have our playlist class. So let's go ahead and go back into our MongoDB service. Our iMongo collection is now going to be playlist. And we can continue adding to our class. So let's start by creating a constructor method. So we're going to say public MongoDB Service. We're going to pass in our MongoDB settings. So this is all going to be handled by our program.cs file. So it's going to take our settings. It's going to pass them to this service, which is going to be a Singleton class. And then we're going to be able to use the variable throughout this particular class. So we're going to say iOptions. This is going to be of MongoDB settings, and we're going to call it MongoDB settings with a lowercase m. Now, inside of this particular constructor method, we can say something along the lines of Mongo client, and we can say client equals new Mongo client. We can provide it the connection URI that's found in our actual MongoDB settings. So we can say MongoDB settings.value.connection URI. Let's go ahead and extract the same for our database and our collection. So what we can say is we can say iMongoDatabase. We can say database equals client.getDatabase. We're going to say MongoDB settings.value database name. Finally, we have our collection, which we defined on line 10. So we can say playlist collection equals database dot get collection. This is going to be of type playlist. We're going to say MongoDB settings dot value dot collection name. So now we have access to our playlist collection. And we're going to add to this slowly as we go along, but we're going to freeze this for now and move on over to our program.cs file. This is where we actually tie the knot when it comes to using this MongoDB service within our web API. So let's go to the program.cs file, and let's go ahead and import a few MongoDB dependencies. And we're going to do that at the top of our application. So we're going to do the following. So we've just included our models and our services namespace. What we can do next is after the builder, after we define our builder, we can now bind our settings as well as our MongoDB service. So we're going to say the following. We're going to say builder.services.configure. So we have MongoDB settings. And then we're going to say builder.configuration.getSection. Now, remember, within our app settings.json file, the actual object that had our connection URI, the database, and the collection was actually called MongoDB. So that's what we're going to be using for this particular section. Now that we have the section, we can actually create our Singleton instance. So we're going to say builder.services.add_singleton, and we're going to add our MongoDB service type, just like this. So now when we started our application, we actually are creating our MongoDB Singleton service, and we're able to use that within our other files going forward. So our next step is actually a two-parter. So we're going to be adding functions to our MongoDB service for actually interacting with MongoDB. And then we're going to create a controller which has endpoint functions that communicates with that particular service. So what we're going to do is we're going to start by creating our playlist controller. So within the controllers directory, let's create a new file. That new file is going to be playlistcontroller.cs. Within this playlistcontroller.cs, let's go ahead and say that we want to include the following. So we're including some various .NET Core dependencies for making this an actual controller. We're also including our services and models. We're going to say that this is part of the controller's namespace. And we're going to find our controller, which is going to be automatically added to this particular application based on our program.cs file. So let's go ahead and create a public class. This is going to extend controller. And we're also going to say that this controller or this class is a controller. And we're going to give it a default route. So we're going to say route. We're going to say that this is going to be API/controller. So that's going to be our path for accessing the different endpoint functions for this particular controller class. And this is where we can actually start defining things. So what we're going to do first is we're going to define a private read-only variable for our MongoDB service. So that way we can access it locally within this particular controller class. And then we have various endpoints that we're going to be referencing as well. So we're going to say private. We're going to say read only, and we're going to say MongoDB service. And since this is a private variable, we're going to say MongoDB service. We're going to have a constructor method, so we're going to say public playlist controller. We're going to pass in that MongoDB service, which is going to be handled for us. This is all handled directly through the program.cs file as part of the web API kind of boilerplate code that was already created for us within this project. So this is not something that we have to do manually. It's just going to work for us automatically. So we're going to say MongoDB service equals MongoDB service. And now we can start defining our endpoints. So this is going to be a basic CRUD application. So we're going to have create, read, update, and delete. You could add way more than this, and it can be very complex, but we're just going to add enough to get you started and in the right direction. So let's go ahead and create a few functions. So the first one is going to be an HTTP GET. So this is best defined as our read function. So we can say public async. This is going to return a task because it's async. It's going to be type list, and it's going to be a list of playlists. So a list of our playlist documents or array. And we're going to call this get. And you can call it really whatever you want, but get makes the most sense in this example. The next thing that we can do is let's go ahead and create a post endpoint. And we're going to populate this code as we progress. But for now, we'll leave it blank for now. We're going to say HTTP post. This is going to be public async. Async. This is going to be a task. This is going to be an I action result. And let's go ahead and maybe call it post, because this is going to be a post request, which is pretty common when it comes to creating data. This post request is going to accept data. So this is going to accept a payload from the user. We actually want to accept that payload from the body. So we're going to say from body. And it's going to be of type playlist. So it's going to have all the fields that exist in our playlist class. And we're going to leave that blank for now. Let's go ahead and do a put. So this is common for update operations. Now for the put, we actually want to define which document we want to update. And we could do that in the body. We could do that in the query parameters. It might make the most sense to do that in the route parameters. So we're going to do it right here. We're going to say that we're accepting an ID. And we're going to define our public function now. So we're going to say public async. This is going to be a task again. I action result. We can say maybe add to playlist. So this is going to follow our previous example for the console application. Rather than updating the entire document, we're going to just add a new item to the existing playlist. And what we're going to do is we're going to say that we want to specify the ID, which is going to be passed in from the user from that route parameter. So we're going to say ID. We're also going to accept a payload from the body. So we're going to say from body, and that's going to contain our actual movie ID. And that's going to be of type string, and it's going to be called movie ID. Finally, we have an HTTP delete, which we are also going to be accepting an ID, which is best put inside of the route parameters. And we're going to follow the same strategy that we've been using up until now. So we're going to say public async. This is going to be a task, I action result. And let's just call it delete because we're going to delete the entire document. We're going to take the ID from the route parameter and pass it along through this function pipeline here. So we have our endpoint functions. There are 4 of them. And they're not really going to do anything until we add underlying logic inside of our MongoDB service. But at least we have something to work with. So let's go ahead and go into our MongoDB service and kind of get things taken care of. So go to MongoDB service.cs. And since we're going to assume that we don't have data as of yet, we're going to work on our post endpoint first, so our create. So what we can say is we can say something along the lines of public async. We can say maybe create async. These function names, you can call them whatever you want to call them, whatever makes the most sense to you, but we're going to be creating something asynchronously. We're going to be accepting a playlist from the payload. So from that endpoint function, it's going to be passed to this function. We're going to say await. We're going to say playlist collection. We're going to say insert one async. We do have the option to say insert many if we want to insert more than one at a time, or we're just going to insert one. It's going to be playlist. And then what we're going to do is we're going to return. Now it is showing that I do have some kind of error here. It's because I actually don't have a return type. The return type here is going to be task. So now that we have the create async function, let's jump back into our playlist controller. We can go to the post endpoint and let's start adding our code. So we are going to be accepting a playlist. We're not going to be doing any kind of data validation in this particular tutorial, but let's go ahead and say await. We're going to say MongoDB Service. We're going to say create async because that's the function that we had just created. We are passing our playlist in. And assuming that this is successful, we're going to say return. We're going to say created at action. So this is part of .NET Core. And we're going to say name of. We're going to say get. We're going to say new. We're going to return information about the ID here. And this is all optional. You don't have to return anything if you don't want to. But this might make sense for us. We're going to say playlist.id. and we're going to say playlist. So the playlist that was inserted. So this is just going to return some information about the actual operation. So we can save it. And we're not going to test all of this until we're done, but you'll see that it's really cool when we do actually start to build the application and play around with it. So let's jump back into the MongoDB service.cs file. This is where we're going to do our get operation because we're going to assume that we have data as of now. So what we can say is we can say public async. We're going to actually return a list of playlist, but we know that because it's async, we got to have a task. So we're going to say list playlist. So more than one document is going to come back potentially. And let's call it get async. And it really doesn't matter what you call it once again. So there's going to be no parameters that we pass in. We're just going to return everything. So we're going to say return. We're going to say await playlist collection dot find. We could easily do find one if we really wanted to, but we're going to do find. We're going to say new. We're going to say bson document. So we're going to have no filter criteria added. It's just going to be an empty bson document. So every single document of this collection is going to come back. If we wanted to add a filter, which we're going to see coming up, we could, but it's not necessary for this particular endpoint. And then we're going to say to list async because we don't want to work with a cursor for this particular example. Cursors are a good idea for a future tutorial, but they are out of scope for this particular tutorial. So I'm going to save it. I'm going to go back into playlistcontroller.cs and I'm going to work on that get endpoint. So for this particular endpoint, all I have to do is I can say return await, and we're going to say MongoDB Service.getAsync. And just like that, we're able to return all of the documents for our particular collection. So we have two endpoints left. Let's go back into the MongoDB Service.cs file, and let's start working on our update, which is really just going to be adding items to an existing playlist, which still qualifies for an update. So let's go ahead and say public, and we're going to say async task. We're going to say add to playlist async. We're going to be provided an ID, which is a string, as well as a movie ID, which is also a string. Now, this is where we can actually define some filter definitions because it is necessary for the update statement. So for the update, we need a filter, so documents to match and satisfy the update, as well as the change criteria. So we can say filter definition. The filter definition is going to be of type playlist. I'm going to say filter equals builders. We're going to say playlist dot filter. And for this particular filter, we are going to do an EQ. Now, there are other operators that you could use, but we're doing a direct match. And what we're going to say is we're going to say that the ID field has to match the ID that is passed. Now, for those documents that match, we need an update definition. So we're going to say update definition is going to be of type playlist. So we have update equals builders playlist dot update, add to set, and we're adding a string, so a movie ID to the set, and it's going to be movie ID is the field, and movie ID is the variable that is being passed in. Now with those two definitions, all we have to do is say await, and we can say playlist collection dot update one async, and we can say filter and update. So those are the two parameters that are required. And then we can just return when we're done. So if we went back into the playlistcontroller.cs file, now we can continue towards populating this particular add to playlist endpoint function. So within this particular function, we can say something along the lines of await. We can say MongoDB service, add to playlist async. We know that we will be provided an ID from our route parameters, as well as a movie ID from the body. And since we're not actually getting any information back, we can say something along the lines of maybe return no content. All right, so we have one endpoint left before we actually start testing things and see if we have any typos. The final endpoint will be delete. It will follow similar logic to what we've already seen. So what we can do is we can go to MongoDB service. Let's create one more function. We're going to say public async. We're going to say task. We're going to say delete async as our name to keep it consistent. We're going to be provided an ID, which is going to be our criteria for deletion. We're going to create a new filter definition. And that new filter definition is going to match what we had for the update. So we're just going to copy it. So we have our filter. what we can do now is we can say await. We can say playlist collection dot delete one. We're only going to delete one single document. And to be honest, there should only ever be one single document because the ID is unique. So we're going to say delete one async, and we're going to say filter. And then we're just going to return. So if we went back into our playlist controller.cs, we can bring things to a close. So we can say await, and we can say MongoDB Service dot delete async. We're going to pass that ID in, and we're going to return no content just like before. And I'm going to save it. So at this point in time, we should be able to run the application and test out our API. So what I'm going to do is I'm going to say .NET run from the command line. Now it is serving our application, so it's serving on, I believe, port 5234. So let's go ahead and test it out. Since we don't have any certificates in place, let's go ahead and continue to localhost. Page cannot be found. That's because we're using Swagger, and we do have our endpoints created under the API path. So let's just go ahead and use Swagger to get the job done. So I just added Swagger to the end of my local host and then port. It actually changed the port for us, but this is where we wanted to end up. So we do have our weather forecast, which we didn't touch. And if you deleted it, it shouldn't show up in here at all. But what we did create is our playlist controller. So let's start with getting some data. So I actually do have data in my playlist collection already. Let's go ahead and go to it. I'm going to say browse collections. And I'm going to say sample mflix. And I'm going to click on playlist. I have 2 documents. Let's go ahead and see what happens when I return them. Let's go ahead and say get. I'm going to try it out. I'm going to execute. And it actually did return an array of objects, so our array of documents. And it looks good. It looks like what it should be. So let's go ahead and go down to actually creating some new data. We're going to test it out. We're going to try it out. It is expecting a request body that looks something like this. So the ID, I'm going to let MongoDB handle that for us. So I'm going to remove it. The username, let's go ahead and just call it Nick. The items, I don't have any real IDs off the top of my head, so I'm going to type in some randomness there. And I'm going to say execute. So it looks like everything succeeded. We can test that by going back up to our get endpoint. I'm going to try it out. I'm going to execute. Let's see if we get our new data. We do. We have Nick as our new document and our items. So let's proceed with testing. We're going to update this. So we have an ID. So I actually don't remember the ID. Let's go ahead and go up. This document right here, I'm going to copy the ID. I'm going to scroll back down. I'm going to try it out. I'm going to paste in the ID. And I'm going to paste in a new string of movies. This time I'm going to use alpha characters instead of numerics because that'll give us something to test off since I used all numbers in the previous example. I'm going to say execute. It doesn't look like I got any errors. So I'm going to scroll back up to the top. I'm going to redo this get endpoint. And we do have an error, it looks like. So let's go into our database and see what our data actually looks like, see if that insert actually worked. So I'm going to refresh it. I'm going to scroll down to Nick. And it actually looks like I do have a new field that was created. So we do want to make sure that we correct this because it should be using items. So it failed because when we did our put, it created a new movie ID field, which did cause us some drama. So first, let's go to the Swagger UI. I'm going to refresh this actually, so that way it kind of collapses everything. I'm going to go to put. So it is expecting a string, which is good, and it is expecting an ID. The ID part seems to have worked out correctly. So let's go back into our code. Let's first look at our playlist.cs file. So it does look like everything's adding up correctly inside of this file. Just by eyeballing it, it looks like everything's good. So let's proceed over to our MongoDB Service. And it looks like the error is probably on line 29. So we use movie ID. So what we probably want to do is we probably want to use items because that's what we're mapping everything to. So let's give it a try. I'm going to save it and I'm going to rerun this. So I'm going to go back into my web browser. What I'm going to do is I'm going to correct that problematic data inside of our database directly. So I'm going to edit this document and I am going to delete this particular field. So that way we have something that is still accurate. So we're going to try to do that update once again. I'm going to go back into the put. Let's go ahead and try it out. I'm going to paste in the ID. Hopefully it's still in my clipboard. And I'm going to actually type in some random alpha characters again. So I'm going to say execute. So I executed it. Let's go back into the database and just do a quick refresh. If I scroll down, it does look like I don't have a movie IDs now, and I have 2 fields inside of this array. So if I go back into Swagger, I'm confident that it will work when I do a get. So I am going to try it out. And I'm going to execute. So no errors this time, and we do have our documents as expected. This brings us to the final API endpoint. Let's go ahead and go to the delete. I am going to try it out. I'm going to paste in that ID, and I'm going to execute. I may have run it twice, but that's all right because it won't find it the second time if that's the case. I'm going to scroll back up. I'm going to cancel. I'm going to try it out for the get. And it looks like the Nic document is now gone. So you don't have to use Swagger. Swagger is very nice when it comes to testing. If you wanted to use your API endpoint for real, it lists out the actual endpoint paths. You can use Postman or your web application. It's totally up to you. But it looks like everything is in order. So we're just going to do a quick recap now. So if I go back into Visual Studio Code, which is what I was using for this particular example, it's not a requirement that you use Visual Studio Code. But what we did is we started with actually our app settings.json file as well as our MongoDB settings.cs file. So we created a new field within the settings that contains our connection string, the database, and the collection that we want to use because we wanted to do it this way. And then our MongoDB settings.cs file was just mappings as far as a class goes to that particular object in the settings. With that information, we were able to take it into our program.cs file where we not only got the particular section that had our configuration, so MongoDB, but we also added it to our Singleton service. So our Singleton service handled all of the heavy lifting for this particular project. So it included actually connecting to our MongoDB instance, as well as a few functions for actually communicating with MongoDB in some fashion. Now, when it comes to communicating, we did that through the playlist controller.cs file. So this is where we actually create RESTful endpoints within .NET Core, and we actually create endpoint functions that communicates with the MongoDB Service.cs class. Now, we did have an error that one time because inside of our MongoDB.Service.cs file, we were using movie ID, which was our local .NET Core field name, but within MongoDB, we're actually using items because that's what we mapped it to inside of our playlist.cs file. We're using items. There are probably a million different ways to accomplish what we did. This is just one way. It should put you in the right path. Your controllers could look infinitely more complex than mine. You can break it down further so that way not everything sits in your MongoDB service class if you wanted to. You could add tons more API endpoints. It's whatever you can imagine. So if you like this tutorial, if you found it useful, please go ahead and hit that like button and then subscribe to the MongoDB channel. It would be greatly appreciated by myself because I recorded this video, but it does let other users know that this was a useful video and it can help them when it comes to .NET Core development. Until next time, I hope everyone has a great rest of their day.